Welcome to Wednesday of IAC. I'm Hillary Coe. I have had a very interesting past, so I'll make it quick. Started in film design, became a communicator. I have worked at Apple, Google, and product design. I was the first design director at SpaceX for both SpaceX future programs, Commercial Crew, and Starlink. My most recent escapade has been as the Chief Design and Marketing Officer at VAST. If you haven't gone to the booth yet, we have a lot of great swag. But, VAST's goal is to really ignite this new generation of commercial spaceflight, and especially commercial human spaceflight. So it's really been a privilege to be able to take my human experience, product design from the tech world, and apply it to space and architecture. So I'm really excited about this panel. I'm going to go ahead and sit down and introduce our other panelists. Thank you. And first up, we have Brendan Swanick, founder and host of Chasing Space and Revenue Operations Manager at Voyager Technologies.
Good afternoon, everyone. Thank you, Hillary, Antonio, Leonard, the IEF, and importantly, the country of Australia. I've been so impressed with the hospitality and kindness you've greeted us with and allowing us to have these open conversations about our history and our future. My name is Brendan Swanick. Over the course of my career, I have launched 40 satellites with Voyager Technologies, mainly off of the International Space Station. We work with scientists, organizations, universities, and even individuals all around the world to make sure that science makes it to orbit. We can continue the mission, working a lot with crew and everybody associated with the International Space Station program. One thing I found that I was passionate about is that there are so many players in this industry internationally, and there may be a gap in communication. So I started Chasing Space, which is a media platform that highlights that exact gap. Where are the gaps? Where are the emerging technologies? Who are the interesting people that are driving these conversations internationally? Most notably, we had IEF's own President Clay Morey on, which is a wonderful episode. I see some friends in the crowd that were also guests on the show. We have managed to reach 10,000 individuals from 75 different nations, and we are growing fast. So Hillary, thanks again. I'm looking forward to sharing the stage with you and the other wonderful panelists today. Thanks all.
Thanks, Brendan. And next we have Ashley Kowalski, Project Leader International Programs at the Aerospace Corporation.
Good afternoon, everyone, and thank you for having me here today. My name is Ashley Kowalski. As Hillary mentioned, I'm a project leader at the Aerospace Corporation, specifically in their International Programs Division, where I represent and provide technical support to the United States Space Force, specifically the Space Systems Command International Affairs Office. However, outside of my day job, I pursue and I participate in a variety of different human spaceflight activities. I'm very interested in the physiological and psychological aspect of long-duration human spaceflight. And to that end, I have served on multiple astronaut analog simulations. Most notably was probably as the flight engineer of the Sirius 21 mission, which was 240 days in isolation, or 8 months. And this was a combined effort between the NASA Johnson Space Center's Human Research Program, Moscow's Institute for Biomedical Problems, and the United Arab Emirates Mohammed bin Rashid Space Center. During the 8-month isolation, we studied the effects of isolation and confinement on human psychology, physiology, crew dynamics, crew autonomy, and the general behavioral health of our crew members. In addition to that analog, I followed up with a shorter 2-week analog sponsored entirely by the Aerospace Corporation. This was at the Mars Desert Research Station. And rather than focusing on the psychological and physiological aspects of long-duration human spaceflight, we decided to focus more on the operational and experimental aspect of procedural needs for human interaction with different experimental setups. And finally, most recently, I did conduct research on a zero-gravity flight together with the support of Space Generation Advisory Council, Aurelia Institute, and colleagues at the University of Oregon, where we decided to study the effects of microgravity on skin and core body temperature, since that relates to circadian misalignment. When circadian misalignment is affected, then that can affect an astronaut's health and performance. So once again, thank you for this opportunity, and I'm very much looking forward to our discussion today.
Thank you, Ashley. Next, we have Ashutosh Mishra, doctoral researcher at the Space Robotics Laboratory, Tohoku University.
Namaskar. Greetings of the day. I am Ashutosh Mishra from the Tohoku University Space Robotics Lab, working currently under the Japanese government Moonshot Goal 3. My research asks a basic question, but big consequences. How do you turn a small set of modules into many mission-ready robots to help the astronauts? Our answer is simple. Plug-and-play hardware with hierarchical learning stack. The same wheel arm module can be dock, undock, reshape from crawlers to manipulators to lifters. Then work in team to lift the payloads, assemble structures, inspect, assess, and recover from faults under human supervision. Safety is explicit. Runtime guards, certified fallbacks, bounded autonomy for hazard class actions, and clear human-in-the-loop control. Near term, our 2025 ground campaign proves 4 points. On-demand self-reconfiguration, cooperative transport on rough terrains, supervised autonomy for construction, and rapid fall recovery. By 2030, we aim to field space-qualified modular robots for initial lunar demonstrations and show these capabilities hold up through launch, landing, dust, and temperature variations. My work focuses on skill portability across forms, multi-robot coordination for shared assembly, safety wrappers for field testing and deployment, and digital twin to de-risk the operation. My aim is direct. Make modular robots dependable teammates for the astronauts. Enabled by open interfaces, portable skill packages, and training pathways that widen participation. Humans set the intent and values, robots deliver the autonomy. That cuts EVA exposures and ship mass and raises the tempo of construction and assembly. So our crews, our astronauts can focus more on exploration and science. Thank you. I'm really glad to be here. Thank you so much.
Thank you. Next, we have Nadina Dersma, double Masters of Science candidate in Robotics and Space Engineering at Delft University of Technology.
Hi everyone, very excited to be here. I'm Nadine, I'm from the Netherlands, and I study space engineering and robotics at Delft University of Technology. I always walk around and wonder, what are the limits of current capabilities? But most importantly, how to push beyond. That brought me into the field of space robotics and AI, and actually led me to many exciting places. From the Arctic, where I developed autonomous satellite tracking systems and CubeSats for educational programs at Andoya Space, all the way from the snow to the Australian outback, where with a team of 18 students, we developed a solar car and raced it for 3,000 kilometers from Darwin to Adelaide. After that, straight to Houston, where together with Ashutosh, we were part of the Space Studies program, and there I worked on closed-loop systems for the Lunar Gateway. As you may notice, I have quite a broad interest in space and technology, and that I'm also keen to share with others. That made me co-author a children's book. It's called Met Mama naar Mars, or With Mom to Mars in English, to show that space is for everyone. And I'm currently co-hosting Space Podcast, the BNR Space Cowboys, where we share an international space news with a national audience. While working towards the end of my master's degree, I really hope to contribute to technologies that bring us further and that make us collaborate on the international level. And with that, I'm very excited to be here and to contribute today to the discussion.
Thank you, Nadina. And last but not least, Christina Balamanaki, researcher and coordinator of Space Architecture and Extreme Environments Habitation Research Group at the Tuktai Lab, Technical University of Crete.
Hello, everyone. Thank you, Hilary. Thank you, everyone. I'm very honored to be here today. My name is Christina Balomenaki. I'm an architect researcher at Technical University of Crete, where I coordinate the research group Hilary mentioned. My research focuses on space habitats with a special emphasis on mental well-being and social interaction. In recent years, I have been working on the development of a modular space analog habitat, a system designed to adapt to different mission needs and also supporting mental well-being and social dynamics in long-duration missions. Earlier this year, I had the honor to be part of the first Greece's delegation to Antarctica, where I tested some of habitat systems in real extreme conditions. Through personalized environmental projections and dynamic lighting scenarios, I underscored the role of spatial, sensory, and lighting conditions in mitigating emotional challenges of isolation, providing insights valuable not only to space exploration, but also to contemporary urban contexts. But what I have learned is that designing space habitats is about more than engineering. As I study human settlements beyond Earth, I understand that our choices will shape the very character of future communities. By designing how people will live, share, thrive, connect there, we are also defining the kind of civilization we carry forward from Earth. So, in order to build a truly sustainable future for Earth and space, our efforts must reflect the full spectrum of humanity across cultures and backgrounds. That is the challenge, my friends, and the opportunity of space research, to design not just for the survival, but for the kind of humanity we want to carry into the future. I look forward to share more with you, and thank you very much again to have me here. Thank you.
All right, so now you know a little bit about the panelists and where they're coming from. I think what's really interesting and unique about this panel is you have both student, researcher, professional representations here, and also so many different fields from AI, robotics, architecture, communications. I just think this is going to be a really interesting panel to discuss here. And what we're discussing today is designing the future of human spaceflight. And what I like to consider that is both on other planets, habitats on other planets, and life in orbit, right? We're at this precipice where we now have major commercial and agency cooperation forwarding human spaceflight now in the 21st century. And I think we're at such an interesting point, and to have, you know, those of you who are still in school and those of you who've had a few years in the industry, what comes to mind for you in your field when you hear that designing the future of human spaceflight? Who wants to go first?
You know, whenever I think about this, I think that we are very fortunate. Everybody that's in this conference today, everybody that's on the stage, everybody that's living through this time where access is slowly becoming real to space. We see that with the commercialization of future space stations. We see that with analog missions. We said that all over the board in different technologies. So it is just unbelievable to live in this precipice.
Well, in my introduction, I mentioned that a lot of my focus is on physiological and psychological aspects for the future of long-duration human spaceflight. And so one thing that I think is absolutely critical when we consider how we do this design is to ensure that we have the full human integration into the full mission architecture from the get-go. So what I mean by that is basically saying, okay, obviously our engineering systems are of utmost importance. We need radiation shielding. We need amazing propulsion systems. We need power systems. However, in addition to the possibility of those systems failing, you can have human failure in these systems. And if we don't place a focus on understanding how the future astronauts are going to be interacting with these systems, interacting with the equipment, interacting with the habitat, interacting with each other in social settings, in having emotional and behavioral health, and understanding the crew dynamics between crewmates, you can most certainly have a human point of failure, and that is completely separate of any machinery or engineering type of failure. And so I think that is extremely, extremely important as we're considering longer and longer human spaceflight missions.
For me, I imagine human space flight as same as like right now all you have traveled from across the world to Sydney through some airline. So for me, I can imagine in future that we will be traveling to the moon, to the Mars with a constant up and down, heavy traffic to these interplanetary travels. And for that, I think the basic thing we need is like a modularity in our approach. We should be inclusive to our designs for that. And of course, we have to include everyone. Space cannot be like made for one certain kind of people. It should be inclusive in design. And yes, you can.
Ashutosh, can I actually ask you a follow-up on this? Because I think some of your research that I have stalked you on in the last few days is really fascinating because like one thing we were dealing with at SpaceX when you're talking about Starship and you're talking about, putting people on another planet, it's, to take that iterative approach, the first landing of a Starship is not going to necessarily be humans, right? This could be robotics. This could be setting up that infrastructure. Can you talk a little bit about the future of human spaceflight and especially living on other planets? I know you've done some research on this, but what role does robotics play in being able to set up this infrastructure even before humans come there?
I feel that robots play a vital role in that because you cannot send the astronaut directly on moon. I will take example for moon. So what my lab is doing is that we are trying to develop modular robotics that we can, it's very impossible to send huge payloads to moon directly because of their size. So what we are trying to develop is that we develop modules in smaller groups, which are like reconfigurable. We can dock, undock, we can attach with them. We will send them to moon in packages, and then they will do the self-reconfiguration on the moon. So by self-reconfiguration, I mean is that they will be, with the same set of modules, consider wheel and arm, they will be reconfigured into different modes. Like with wheel and one arm, with 2 wheels and 1 arm, you can make a vehicle mode, a rover that can explore the moon for human habitat. If you attach 1 more wheel, we call it a dragon configuration in our lab. It can do the manipulation task or the laborious task for the astronauts. Similarly, if you reconfigure them in various things, you can do a multi-robot collaboration to build infrastructures and other facilities for the humans even before they land on the moon. So it's kind of like we are developing dependable teams for the human astronauts. Even before they arrive on the moon, there will be a infrastructure, there will be a workforce for them to handle their arrival. It's kind of welcoming the humans on moon by the robots. So that's kind of future I can imagine. Thank you.
Yeah, and from my perspective, thinking about the future of human spaceflight, it will not only about going and returning, but actually about surviving and sustaining, maybe on other planets. Looking from my own perspective, I'm mainly into autonomy and AI, and I think the further we go, the more important that aspect will be. Considering that we have a time delay, we'll also have limited computing power, limited resources, limited contact with other people on Earth. So yeah, then we need more automation and more AI to do the tasks that were normally done by crew members. I think it's also important for psychological support, especially with smaller crews that are far away from home. Imagine being on a mission to Mars for maybe 3 years, and the closest you can get to your family is with a time delay of several minutes. So yeah, then I think that AI can be, for example, helpful in LLM models that you can directly talk with, but also technological support, where if you're having an issue, you can ask the AI model to ask for a direct solution. And I think it's important to design those AI systems responsibly, especially with limited contact with other humans. We should account for biases that are introduced in AI systems. And yeah, I think that's very important to look into. And I can also add on that later in the discussion to continue it.
Taking it from the part Nadine left it about permanent and more long-term human settlements in space. For me, the future of human spaceflight at the same time is about talking about the future of humanity in space in general. Because, want it or not, whoever goes there for long will take what we have here with them. So we have to reconsider about what we want to export into space. And this will have to be the concept of thinking the whole human history and the whole human civilization. Do we want to take everything you have done here on Earth to replicate it in space? I don't think so. No, so
probably not.
This is the part of starting to understanding who we are, who we want to be, designing the humanity that we want to have there, but also trying to foster all the qualities we want there, to foster them here on Earth now, in order to have a sustainable, permanent stay in other planetary bodies. You have firstly to have a sustainable coexistence here on Earth. And this reflects also in the very design qualities we try to have into the habitats there. How are the people for whom we design, what relationships they have, how they interact? All these are part of the design process. And all of these are very important questions that we have to ask now before we go to that stage. Thank you.
Yeah, and I think it's really important. I mean, even just coming from your architectural background, and it's something we always plan for is who's the user, right? If we're doing these long duration flights, I mean, once you leave Earth's orbit going to Mars, you're on the hook for at least 3.5 years and some change. I mean, that's incredible. And to sustain communities, create communities and culture, we've done a lot of research on just like being in Starship for 7 months. My God, like you better get along with your friends. But there's all sorts of different people, right? These are going to be teachers. There might be families, children. And I think it's really important to understand how are we designing this future, not just for, those people who are conditioned, I would say, for these extreme environments, like some of you here who have been on analogs. My God, Ashley, she did 36 hours sleep deprivation with some, she didn't sleep for 36 hours and then had to dock with some lunar
I
satellites.
think we had to do some like Soyuz docking simulations and then a bunch of other experiments. And, I could even see myself like literally making mistakes like the further into the sleep deprivation that was occurring, dropping pieces of equipment. Then you have to report, to mission control what happened, why it happened, how do we continue with the experiment. But, that brings up another point. I was talking with mission control, whereas, again, you mentioned AI for decision support tool. That's something that in the future, we're going to probably need to talk to AI and have these conversations among crewmates and AI to figure out, okay, what do we do in this situation? Maybe it's a mission critical situation where you have to stay up for more than 36 hours to fix something in the habitat.
Right.
And you have to maintain your mental capacity at that same time. I mean,
and this might be the equivalent of my mother. Like this might not be you who is just like volunteered for this thing and you're built for it, girl. You're a badass. Like what happens when my mom has to do that? God help us all. But I think that's what the interesting thing is we've got these extreme environments. How do we go from Maslow's pyramid of just like, it's the ISS where it's like, how do we survive out there, and it's the inside of a VCR, there's wires, there's everything. How do we now create the future that like our brothers, our sisters, our sons, our daughters need to live and thrive in? And I'd love to hear some of those perspectives from an architectural standpoint, from an AI standpoint. How are we changing our perspective of how to build for these extreme environments? Nadina, you're shaking your head.
I can go.
Okay, you go first.
So basically, this will overlap with what Nadine is doing. So as I talk about that, we are developing the modular robots. So not everyone is like kind of well aware of what is robotics. Like you said already that there will be grandparents, children, all of them will be traveling to the moon and other places. So what we are trying to do is that you all must be aware of ChatGPT, DeepSeek AI, and like basically LLMs that can understand the human language and then process it. So my lab, basically I am working on that. We can just write in our language what we want the robots to do, and they will just reconfigure themselves to achieve that task. We had some initial testings in the JAXA Sagamihara field for that, and I think the POC is almost ready. So in this way, like we can leverage the usefulness of these LLMs with the robotics, and then include everyone, even from whether they are from the biological background or from the technical background, non-technical. There may be, if we are traveling to space, definitely there will be some policymaker guys, because without policy, nothing works. So that is one of the points. So yes, so this kind of technologies where we can interact with the LLMs, and then it can transform human language into a computer or robotics language. That is one of the useful way to include everyone.
And Nadina, I'm curious to know from your expertise, like if AI and robotics, if they're taking over a lot of the human tasks, especially with artificial intelligence, right? Doing some of that, the calculations and the, extreme case scenarios, what then does the role of the human play?
Yeah, that's actually a very good question and one to think about. Because AI many people are worried that AI will once beat the human and be able to do things that humans cannot do at one moment. And I think we should be worried. But so far, not for space, because AI is very good at repetitive tasks and also good on instruction-based tasks that require a lot of data. On the other hand, space is very unpredictable and very dynamic. We need to come up quickly with new solutions. And that's then something that the human adapts to quickly. So a problem in space, for example, is that there is not enough training data. It's very hard to get training data from the missions because there are only very few, and it's very expensive to go on a mission. So as long as we don't have the training data, I think that's the first step towards advancing these AI systems. And after that, we can look further how it can be of a broader support for the tasks that at this moment only human astronauts are capable of. And another aspect as well I'd like to talk about, that is the aspect of the human hero. Well, we all agree astronauts are heroes. They have inspired me. I think they also have inspired a lot of people in the audience. And an AI system that goes into space, it's difficult to make, it's inspiring, but it will never be as inspiring as a human astronaut to children and the generations to come.
Amen to that.
I think both of you made really interesting points that we should drill down on it. And to your point, the way that we design, even if we just narrow down on anthropometrics, and how do we design, let's just use a space station, for example, to fit people that are not necessarily a government astronaut, that have done 2 years of intense training with a very exquisite background? How do we train people that are maybe a private astronaut, maybe from an organization that is beginning to send people to space? It's a really difficult engineering challenge, which is tough. But on the flip side, you also open up the doors to allow other people, regardless of the space industry, to enter this world and begin contributing to what this looks like. So it's a lot bigger than just the folks in this room right now. And I think to your point, Nadine, when you look at Why is it so important to send people to space in the future? I think you can ask a similar question about why is it so important to send people back to the moon? Why are we spending all these resources to send 4 individuals around the moon? And it's to be able to keep doing these things. You want to keep inspiring people to take on the toughest challenges of their generation and move our entire society forward, not just domestically, but internationally. So there's a really important element there, but you have to read in between the lines to see the value.
And I think it's also super important when you were talking about, like, it's bigger than the people in this room. I think, with my experience working at SpaceX, in cohesion with NASA and now at VAST, there's, you have the traditional approach to this, but then bringing in like a chef scientist, bringing in architects, bringing in like our industrial designers who come from product, figuring out, wait a minute, it's really uncomfortable to sleep in space for 8 hours because of microgravity. How do you do that if you've got to spend 7 months in space or a year? So it's developing those products that I don't think, your average engineer is going to have a lot of experience doing something like that, but bringing in the right people who might not have an aerospace background, but could sit there and go, hang on, what if it's a reverse sleep number bed and it's this blow-up duvet and suddenly the astronauts can get 8 hours of sleep, not just as a vanity, but to be able to do the work, right? To be able to, be their best and then perform their best. Like Ashley, you were talking about, when you have that sleep deprivation, how crucial that is. And I think designing for the human experience, and that goes into the architecture of, habitats and space stations. Like, Christina, what is your take on this in terms of, the architecture and the environment that they're existing in?
Well, I would say some things like, first of all, as we venture into the phase that people will go to space, already commercial flights, and this will advance, and people will go to space without the basic training or selection situation of the astronauts. And you will be there like 7 months, as you said, and you will be there very hardworking with people you don't choose, probably you don't even like, in very close quarters. And this is extremely big stress, I can tell you that. I can understand this also from Antarctica. We had very little space, very many people. I had the very luck to be everyone, very nice people, but this is not always the case.
That's not always the case, though.
That's not always the case. So what happens at that point? You have very big stressors, and you cannot have even selection of your private space. You don't have this area of privacy. So for the future accommodations, the habitats have to reflect all the layers of space of human interaction, all of them. They have to be like this. They have to be big in order to be able not us to fit into the habitats to be adjusted to us. But someone will tell now, okay, architect, you have to be realistic. What we do now, this is very expensive stuff, all the habitats, all these things. For more short-term vision about this, we really believe in adjustability of the interior of the place in order to have multiple functions and adjustability to 3 levels: mission level, group level, and personal level. And you have to have all of these levels of adjustability, customization, and transformability in order to be able to adapt to different behavioral scenarios. This will help extremely much, we believe, the psychological challenges and emotional challenges of long-term confinement.
If I may just add a little bit onto what
Please.
you were saying, because I absolutely love everything that you were saying, and I feel like that just fed right into some of the actual experiences that we had in the habitat for the 240-day mission. There's even small things that you might not think affect your work or how you feel. Like, for example, like having a toilet or a cleaning area next to a workstation where someone's supposed to be doing an experiment. I know that sounds crazy, but that brings a level of discomfort to the human mentally and behaviorally. And so, designing something like that, or even something as simple as the clothes that the astronauts are going to be wearing inside of the habitat. I'll tell you, we had one pair of sweatpants that we had to wear for about 2 weeks straight before we could rotate. And in our personal cargo package that we could bring in, I brought in an extra pair of hiking pants or something like that. I fit it in, really small, got it in, and my other crewmates were like, oh my gosh, I wish I had thought of bringing another pair of pants, because what do you feel like when you're wearing sweatpants? You don't feel like you're motivated to work. You don't feel like you're motivated to work next to somebody using the toilet. You don't feel, I know these things sound crazy when I'm saying them out loud, but these are actual things that need to be incorporated into the design of future habitats. Even right now on the inside of the ISS, when you see the interior, it's mostly equipment and white walls, essentially. When I was in the analog, for some reason, the interior was more wooden looking, right? Wooden kind of interior makes you feel probably more cozy. Maybe that made our experience a little bit easier than what it actually would have been if we had white cylindrical walls all around us or metal walls. And so, of course, we're not going to be bringing wood into space, but maybe there's a coating that we can put on in the inside that actually makes you feel, more ready to work and ready.
We're developing our space station with white oak veneer for that very reason.
Well then.
Quite literally. But it's great that you say that, because
yeah.
you don't think about those things, right? And you think, okay, it's space, it's 2001: A Space Odyssey. But when you're in there day in and day out, which is why I love those analogs, for that reason, is all of these things we take for granted. I mean, the pandemic was like a global analog for that in a way, but to be able to understand what home feels like, what comfort feels like, and it's not about vanity, it's about productivity and how you feel. One of the big things on my analog that I did at Mauna Loa was the importance of coming together as a group to share a meal together. And I know you're in microgravity, but we've developed also a deployable table, because even if you're in microgravity, being able to strap yourself to something and come together as a group. I mean, we have been doing that since we've been living in caves, right? That's a human, read the book Sapiens, it's great. But it's just, we shouldn't ignore those primal things that we take for granted, but when you're in a confined space in an extreme environment, they become so crucial to the future and productivity, right?
Yeah, I 100% agree with all of that. And I just want to kind of touch back also on, something that all of our panelists were saying earlier with the designing future of human spaceflight. Currently on the ISS, I mentioned that human effectivity and human interaction with the systems is really important. Now, currently on the ISS, we also lose a lot of astronaut productive time, due to the way that systems are designed right now. Even something, robotic systems. A lot of time is spent for maintenance and repair of equipment, robotics, other issues that are happening in the station, fixing the exercise equipment, whatever it is. What if we had robotic systems doing all of that instead? All of the cleaning of the toilets, all of the cleaning of our bed spaces. Maybe there's a way that we can robotically do that and use AI to also optimize that, right? And even when we talk more about the physiological areas, right now 2 hours a day are spent on the ISS for astronauts to exercise. What if we minimize that? Even an hour per day, how much more hours per astronaut are we getting on a single mission, right? So if we design systems, maybe that can naturally or even unnaturally create the same results that we're getting from 2 hours of exercise on the International Space Station, and minimize that using, I don't know, maybe sensors that are simulating our muscles to do the same amount of work, or maybe some type of reducing our, I don't know, I can't even think of anything on the spot right now. That part's not my field.
And Brendan, I think this is where, you working in the commercial sector, can you just give a little bit more on, that was all made by NASA and international partners. What do you think the benefit is of this industry going into the commercial sector?
Sure, and my colleague, Marshall Smith, the CEO of Starlab, made an interesting point yesterday. The ISS is in my opinion, one of the most important technological innovations in history of humankind. But it was built by engineers for engineers. And that was the quote. And I think that's especially important when, for example, when we look at what we're doing with Starlab and what other folks are doing with their commercial space stations, if we hone really in on what does science look like? How do we optimize this space for science? And that is one thing that we have been really honing in on is what is the user experience for maybe in the beginning, government astronauts, maybe in the future, individual astronauts to conduct science. And of course, to your point, every aspect of designing these systems has to be holistic. But it's really hard to get everybody. I think what is that engineering rule? It's like you have to get 90%. And every time you get 90%, it's 1% easier. And I think bringing in commercial allows you to create those partnerships to find ways to get to that 90%. One perfect example, we are partnering with Hilton Hotels. They are a master class at hospitality, and it's extremely important to be able to, have a comfortable ride to space. So just one example of the millions of different things that you can consider when you're designing these systems, back to my previous point of looking beyond just our industry for where help is needed.
Cool. Does anyone else have any comments about kind of moving forward from the age of the ISS into the future of, orbital space stations and future habitats, like taking what we've learned from all of these, decades now of experience on the ISS? Christina?
I would say something complementary to what you said before. I was actually very amazed that you pointed out that so much because it was one of the main findings from Antarctica, the importance of home, of the feeling of home, because it's not that I haven't thought of it, but I was amazed of how much front it came, because there was a base with a lot of selection with wood. And most important, it's not only about how is the base designed from the architects. It's that these people there, which I thank them very much for every kind of assistance I had, they had the opportunity and the feeling that they can be very drastically customizing their environments. This is very important because it's something that we have at our homes, and it's more the self-expression on your space, it helps very much. So this was one of the main findings, but I would say that ISS has done great, who had great work there, understanding the human spaceflight, but this machinery-like landscape has to change as far as more common people will add to this situation, and that's it.
And I would like to add another aspect from the ISS, because we're currently not there yet. If we want to go on long-duration missions, we need to recycle, we need to reuse, and we need to adapt. So currently in the ISS, for example, there's 98% of water recycled. We're almost there. But considering oxygen, we're not even at 50%. So we need some systems to recycle all the waste, all the water, all the everything. And also think about where to place it. We need laundry for the clothes. Currently, all the clothes that astronauts are wearing are just thrown away and burned up in the atmosphere. And this is something that we cannot do on a long-duration mission. And some very interesting solutions that I've worked on when I was researching closed-loop systems was actually that we can use organic waste as a radiation shield. And it even turned out to be more effective than something made out of metal, because it contains a certain type of molecule. So I think we need to think out of the box with some solutions and then make it capable for humans to survive on the long term.
I would like to add what Ashley said. So basically, you mentioned that we are having, we want to develop a robotic system that can clean toilets and help in other things. So I can point out one of the major challenge we have in that is the power limitation. We have a very restricted power on ISS so that we are unable to operate many things. at simultaneously, or it will just drain out the power consumption from the essentials experiment. The second thing is the payload, payload problem. Like you cannot just put everything on the ISS. It's very limited. So the solution for this I can see is that it lies inside the reconfigurability, the modularity, that we can use the same robotic system to do the household chores and the modular systems to do the experiments. Then it will save a lot of space on ISS or the future space stations, right? And it will also make it easy for, from the design perspective, also to include everyone for it. Like we can design modes, we can design combinations with these building blocks, like a Lego system, you can say, depending upon the requirement we have, the task we have to do. So it saves a lot of space and energy also.
I think one particular lesson learned from the ISS, which absolutely should be continued with commercial companies, is how well NASA and their partners have done in communicating what is going on station. I'm sure everybody in this room loves to see a video of Johnny Kim zooming through the station or sharing a meal. I think they had sushi recently. Yeah. These are really important. These are the things that get people in my generation and the generations succeeding us fired up about these things and fired up to pursue science and pursue research and pursue STEM, which ultimately will land them and land society in a much better spot than it would have been otherwise. So there is an engineering element, and there's absolutely a timeless legacy element which impacts everyone.
And how do you communicate that to the world, right? Because part of this industry is built on that, collective imagination and desire for humanity to go out, over that horizon and seek new worlds. I mean, to boldly go, right?
It is difficult, and I think one of the most important ways is just finding these people that are just absolutely turning the wheel on the ship. There are some people in this industry, I've met several here throughout the week, that have been just doing some wonderful things. Very important that you communicate what you're doing with the world. It's unbelievable. So for all the engineers in the room, it's great to share what you do.
So one last question that I have that's open is, what concerns you the most about the future in the next 20 to 30 years with human spaceflight? And if you don't want to end on a Debbie Downer, what also makes you most excited and hopeful about the next 20 to 30 years in human spaceflight?
I can go first.
Okay.
I have two cases. You can say that first one is very recent. I'm worried about the policymakers. Okay?
I was just going to say the same thing.
So you have heard the news in the morning about the US government shutting down for a few days, maybe, we don't know. So that hampers the space programs a lot. So we are talking about what will happen in the next 20, 30 years, but we don't know what will happen the next day because of the policies we are making. And the major gap we are facing is that the policymakers are not the engineers or the actual astronauts working on the ISS or something. So this is one of the case. The second case is I will take of ISRO, Indian Space Research Organization. The basic foundation of ISRO is to serve its people. They are mainly towards the Earth observational satellites, and that is also limited to the Indian subcontinent. But now, due to Indian policymakers, they are now moving towards more, you have heard about the Gaganyaan mission. They are now trying to send Indian astronauts on the moon. You have heard about the Bharatiya Space Station. They are building their own space station by 2040, I guess. So from these two case studies, you can say that one of the most critical thing which we cannot predict and which plays an important role is of a policymaker. And it's not in our hands because we are not the policymakers.
But we have to keep building and designing, right? Despite all of that.
Yes, for sure.
The uncertainty, yeah. Does anyone else have something to add?
Go ahead.
Yeah, my main concern is that we're going separate and that we're not going together. So what we see at this moment is that countries are more into national space programs compared to how we did it with the ISS when we worked on something big that has never been done before. But then we did it together. And I think going together brings a lot of hope and the many good things, but also challenges. While people from different cultures have to collaborate, and we also need to adapt for that. It's often easier to, you often look for friends. Those are people that are similar to you. So also in cruise, it's expected that they collaborate sometimes better if people have similar habits, similar cultures. But if it's not the case, we need to adapt for that. So in AI assistance, actually the topic I start with, I can also end with, because AI assistants, those are voices. And in those voices, of course, you need to account for different cultures, for different values, for different accents, different languages. Even, have you ever wondered why AI voices are always female? It's because they're perceived to be more helpful and assistive. But if you listen too often to it, it can also introduce biases that all female are like that. So those are all small things that we need to account for in inclusive design. Have you actually ever wondered why all systems are tested on male mannequins? It's also something. If it would be tested on a female mannequin, then maybe I doubt if how many men would even dare to board the spacecraft. So yeah, I think that's important to account for everyone, but also account for standardization, because going to space is already very complex and we shouldn't make it more difficult than it is. And then what excites me the most, I think that is spin-off technologies that come from a mission to Mars. While going so far encourages us to think about problems that we would not think about here if we would stay on Earth. And I hope that all those beautiful technologies from recycling systems also can contribute to a more sustainable and better place that we're having now for all the humans that are living on Earth.
I'll counter your cautionary tale with something. Yes.
That was great. Well done.
Maybe I'm biased because I work in the industry, but what I have noticed is that there's a change in the perspective of space. It has always been, why do we need to go to the moon? Why do we need to go to Mars? Why do we need to spend hundreds of millions, potentially billions of dollars on these big, ambitious missions? But what is changing is that people realize, and I'll quote my good friend Dave Marsh, that space is for Earth, and the applications of space for Earth are becoming more and more present in our daily lives. We see it with connectivity. We see it with any type of biopharmaceuticals. Just within Starlab alone, we're going to be able to grow organs and test on your tissue to see how you can use certain medicines and how your body accepts it. There are millions and millions of these different examples, and people are getting it now. So I think the one takeaway that I am seeing is that space is for everybody, and space is for Earth, which is a really important message to take home.
Taking
Agreed.
that from Brendan's, it's very important all this, how we take advantage from the space research. For me, it's always why should an architect be in Antarctica, or why should an architect have involvement in the space industry? First of all, what scares me most for the next years, it's about how about the challenges we face here on Earth now, because we do face challenges, to go back there. And what happens to the people who go there and the people who are here with all this challenging environment also on Earth. But what I like the most about the space research, being also an architect in a very not usual thing in this kind of surroundings, is that studying the humans, their interactions, their habitats, the man-made environment in general in extreme conditions, makes you understand what goes wrong with these things. Because if something is a problem in the extreme environments, it's also in the usual modern and urban environments, but because of the complexity of the life of the surrounding, you don't understand it. So if you do research as an architect in extreme environments, focusing in a very based level to what is the problem, we can also make better our cities, our hospitals, and everything goes around our places, even our schools.
New York in the middle of the summer is an extreme environment, so that counts. I completely agree. The more that we can research that and understand how to build for that extreme space is only going to be able to help us. And I think a few of you have made this point that it's so important that when we are part of this, the beauty of the New Horizon is we get to kind of get a chance to create the vision of humanity and the community of humanity that we want to see, and then to be able to, like you said, bring this back to Earth, because this is for Earth. I think, there's something about that new opportunity that we get to create and bring in so many different individuals who come from different backgrounds but are so like-minded, because everybody that I meet in this industry seems to have that same vision of what if we could be solving these problems and take this back to what we know on Earth. So I think that's a beautiful point to make. Anyone else have any final thoughts? Ashley, I feel like you have one.
I feel like all the panelists already kind of touched on everything I was going to say. I mean, we won't talk about the negative with the policymakers because we already know that's an issue always. But exactly what all the other panelists said, bringing everything back down to Earth. I mean, think about all the scientific research that we didn't even expect to get out of the ISS that now is part of our lives. And think about the plethora of new items that we're gonna find when we go back to the moon and onto Mars. I really, truly, I'm so excited about this. I always feel like we're in a whole new golden space age right now. We have the motivation, we have the people, we have the expertise now, we have the funding coming in for now. And I really truly believe that this is the next golden space age era. So
awesome. Well, I think we'll end it on that. Thank you so much, Brendan, Ashley, Ashutosh, Nadina, and Christina. Thank you. Everybody, please give them a hand.
How about we give one more hand for our amazing host tonight, Hillary. Thank you so much.